everything we need here. F prime of x, f of x, and the second derivative. Okay. So this is a rational function. For rational functions, rational functions, by comparison to everything we looked at, can have, not necessarily, but they can have vertical asymptotes. And if I find a vertical asymptote, then I have to determine the sign left and right. It could be this, it could be this, it could be both on the same side. So this is a vertical asymptote. Where the domain is, where the denominator is 0. Denominator equals 0. And there is no hole. We're going to look at an example in which a function, I'll make one up right after this, in which a function may have a vertical asymptote or hole. It cannot have a vertical asymptote and a hole at the same point. Okay, so rational functions have vertical asymptotes. Also, rational functions can have horizontal asymptotes as well. We will determine those, as we've done before, with the limits at infinity. So the function can do this and can do this. And then this is a horizontal asymptote. Let's say y equals 4, horizontal asymptote. So this is in addition to everything we have to worry about, the first derivative, second derivative, signs, critical numbers, etc., 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 first x and y intercepts, blah, blah, blah. In addition, when we talk about rational functions, we have to think in these terms. Yes, there is a third option. The third option is a slant asymptote. So the function can do this, for example, and this. So at infinity, when x approaches infinity, the function asymptotically gets closer and closer to this line, and the other way. We're going to talk about all these situations. You don't have to memorize any of this right now. But this is called a slant. And I'm going to say then when we get to this again, a function cannot have a horizontal and slant. It can have a horizontal or slant, not both. So these two can go together, these two can go together, but these two will never go together. Horizontal and slant at the same time. Okay. Coming back to the starting point, I need to find the domain. Can anyone give us the domain of this function?
Infinity to infinity,
Yep.
negative infinity to infinity.
Yep, absolutely, no problems, because x squared plus 4 is never 0. Awesome. Now I will have to find these two limits, but let's find the x and y intercepts. 0 has to be in the table. So can anyone give us the y value? Y value when x is 0.
-1.
Very good, indeed, -1. And then let's factor the numerator and find the x-intercepts and then the limits. And we're done with the function after that. So can anyone factor out the numerator for us? I mean, factor the polynomial in the numerator. Because that will give us the x-intercepts in a blink.
X plus 2x prime.
Very good, excellent, thank you very much. So then when this is 0, what will I get?
X equals 2 and x equals -.
Yes, plus or minus 2. Very good. Go back to my table immediately. -2, 0, +2, 0. And now the last thing, the limits. And we've done this before in chapter 2. Limit as x approaches infinity or negative infinity will not make any difference from x squared minus 4 over x squared plus 4. When we find the limit, what is the first thing that we need to do?
Plug it in.
Yes, awesome. Of course, I'm not going to plug in the here. So where is the numerator going?
Positive.
Good. Both infinities. Good. Remember L'Hopital's rule? Limit, ratio, and infinity over infinity. All three conditions are fulfilled. Limit, inside the limit, a ratio, and the case infinity over infinity or 0 over 0. L'Hopital's rule, I copy the limit, differentiate the top, and then differentiate the denominator.
X.
And what is this limit then?
1.
Excellent. Y equals 1, horizontal asymptote. Done. I found the limits. I found the horizontal asymptote. I found the x and y intercepts. The function is always defined. Finished. I'm moving on to the first derivative. Good. So the function. So let me copy the function right here over x squared plus 4. So I can move this away for a moment. So top prime times the denominator minus top times the denominator prime. Don't forget parentheses here, times 2x. Do not distribute if you can factor. I'm going to factor out 2x, of course. X squared plus 4 minus x squared plus 4. Eight times 2, 16x over x squared plus 4 squared. I have the derivative. F prime of x equals 0. F prime of x undefined. I always have to check both possibilities. Is this function ever undefined?
No.
No. Is this function ever 0?
X equals 0.
X equals 0. Go back immediately to my table. Put the 0 where it belongs. Now I have to fill in this row. Which portion of this you're not going to waste your time because it's always positive and I don't want to waste my time.
Denominator.
Good. And of course also 16. Just x will give us the sign. So before 0, give me the sign of x. After 0, give me the sign of x.
Negative and positive.
Of course, thank you very much. Moment of truth. Moment of truth. If these two don't work well together, then I'm in trouble. This is when I catch my mistakes. From 1 to 0. Is it decreasing? Yes. From 0 to -1? Yes. From -1 to 0? Yes. From 0 to 1? Yes. What type of point is 0, comma, -1?
Collected minimum?
Yes. In this area, how should the function look like, or the second derivative? What should the sign be here? I'm anticipating, I haven't even calculated the second derivative. But what should the sign of the second derivative be here?
Negative? Positive?
Yes, I expect this to be positive here for sure, because this is a minimum. Okay, good. So now let's find the second derivative. Leave 16 outside. Make your life easier. So I'm writing this again for my purpose of differentiating. That's why on test 2, we had a rational function to fully simplify. And I hope you go back and redo those problems, because this is extremely important to be able to clear this up and simplify it. Okay, so the second derivative. Top function prime 1 times the denominator. Many of you started distributing and multiplying, and that you never gotten anywhere. Minus the top times the denominator prime. 2 x squared plus 4 to 2 minus 1 times the inner function prime. Do not distribute. Do not ever distribute if there are common factors anytime, forever. And I have a common factor of x squared plus 4. 16 outside. X squared plus 4. One of those is out, but one is still left in.
I have a question.
Yes, yes.
Doesn't the denominator cancel like to the fourth root?
Of course. Of course. I thought I did write 4, but sorry. Yes, of course. My apologies. Absolutely. 2 squared 4. Thank you. So 1 is out, x squared plus 4. Now this is out. 2x times 2x is minus 4x squared over x squared plus 4 to the 4th. Only now I can simplify one of those from the top and one from the denominator. Okay, so then I have 16, and negative 4x squared minus x squared is negative 3x squared, and plus 4 over x squared plus 4 to the 3rd power. And you know me, I have to factor out the negative. And 3x squared minus 4 over x squared plus 4 cubed. The second derivative equals 0. The second derivative undefined. I know you're going to say here, just write 3x squared minus 4 equals 0. Move forward, divide by 3, take the square root, right? So x equals plus or minus the square of 4/3. Ugly, but that's what it is. And I know you're going to say no, because this is never 0. I have to approximate these two values, plus or minus what? So I'm going to my graphing calculator, and I have the square root of 4 over 3. What is this? 1.2. So plus or minus 1.2. Back to the table immediately. Okay, I need to plug in the function and determine these values. When x is -1/2, what is the y value? When x is 1/2, what is the y value? I'm going to do it right now because I need it because I don't know how to graph. So in y equals, be very careful how you enter such a function. You need parentheses for the top no matter what. I don't know, maybe you have a super sophisticated calculator, but make sure you have parentheses. And the denominator squared plus 4. Oh no. Good, so I'm plugging in. To be exact, I could, just to be super exact as much as I could, just plug in the square root of 4/3 to have as minimal error as possible. Ah, look at that, how nice. -1/2. And the other one is the same because the function is even. You can plug in negative the square root. The function is even because f of -x is the same with f of x. So you can plug in 4/3. You'll see you'll get exactly the same number, -0.5. Oh, yeah, of course, because I overwrote it. So you can see it. So now I'm going to put the positive one because the function is even. The numbers will be the same. Okay, perfect. So I have here -0.5, and I have -0.5, and it makes sense from 0 to -0.5 to -1, from -1 to -0.5 to 0. Final step, I need to study the sign of this expression. Which portion of this you're not going to waste your time with. This would not always be the same, but when it is, why not? I take advantage of it. So which piece will be a waste of time to even study the sign for?
Denominator.
Absolutely, the denominator, and of course 16, which makes no difference. So now you already know what sign we expect. So please plug in 0 and tell me what sign you get. You get a negative in front with a -4. So as expected, which we knew, because we already identified. Oh, I forgot to write that this is an IP and this is an IP. So this is exactly what we expect. So now let's see on the outside. Plug in -10 or 10, the number will be the same. So if we plug in 10, this will be huge. This is a tiny number, so this is positive with minus in front. So in both situations, negative. So here, as expected, it has to hold water because it's a minimum. Here it will not. The only thing that does not fit in this table is that f of -x equals f of x, which is an even function. This is the only thing you have to write on the side. And now, again, all this work, page 8, page 9, page 10, mean nothing. Nothing whatsoever. The only thing that counts is this. Nothing else is of any value at this moment. So I think I'm on 11, yes. Okay. When I graph a function with asymptotes, I have to start by graphing the asymptotes first. There is only one. Asymptotes are not part of the graph, so they cannot be graphed as solid lines. Then I continue with the ordered pairs. And I have -2, 0. And of course, I have 2, 0. Then I have 0, -1. Then I have -1.2, -0.5, positive 1.2, -0.5. And that's all I have. Nothing else. So now I start opening down, decreasing, from 1, from the horizontal asymptote, to the x-intercept. Okay. Why am I trying to graph with this? It continues to decrease to this point, which is the inflection point. Fine. It changes concavity because it opens up and it reaches this relative minimum, which will also be an absolute minimum. So it changes concavity and going to the absolute minimum or relative minimum also. Continues to open up till the next point of inflection and increasing to that point of inflection. At this point, it changes concavity, starting going down, opening down, increasing, crossing the x-axis and increasing towards 1. So this is the function f of x, x squared minus 4 over x squared plus 4. And this is also absolute min.